Hey everyone, welcome back. Today we're going to look at circles. If you've seen the previous video of square roots and the videos on exponents, today's lesson will be a lot easier on you. So we start with a circle, point in the middle. If we have a line going from one edge to the other that is passing through the middle, this is called the diameter. It's the longest length we can create from a circle. Radius, r, is from the center to the edge of the circle, like that. And so we notice that diameter is the same as 2 radii, like that. So we have a circle, radius r. If we take a rope and go from this edge like this, so this r length, we put it on the edge of the circle, we get to about here. And then we do another radius, and then we do another radius, and then a little bit. So to get to the other half, it's 3 and a little bit r's, right? 1r, 2r, 3r, 3 and a little bit r. This 3 and a little bit is called pi. So pi is the amount of r's required to make half a circle in the perimeter. Right? So pi is the multiple of r to get half a circle. And so to get the whole perimeter, we double it. And so the perimeter of a circle, we call it a circumference. And so the circumference is pi r times 2, like that. So 2 pi r. And this is a formula you're going to have to know by heart. But if you understand where it comes from, you can deduce it yourself. You can always remember, oh, pi r, 2 pi r gives the whole thing like that. And so pi is approximately 3.141592654, etc., etc. And this actually keeps going in a non-repeating manner. And so pi is an irrational number. It's a special number. It cannot be written as a fraction. Okay, so we saw our formula for circumference that you got to know by heart. Let's look at something else here. If we have a circle and we break it up into pieces, and we rearrange those pieces so that it looks like this, what we have is roughly a rectangle, like that. And so the entire length, like here, is 2 pi, but you see how we split it up in two? So instead of 2 pi r, this one side is the length of half. So we call that pi r, right? From here, pi r like that. And so this is our length like that, pi r. And then the distance from the center to the edge is r, which is the length here. So this is approximately a rectangle. So we have r times pi r, like that, which comes to pi r squared. So the area, surface area of a circle is pi r squared. And this is another equation you need to know by heart. But if you're capable of deriving how I did that, you'll be able to derive this equation on your own, which is much more powerful than simply learning it by heart. Okay, let's do some examples. So in our calculations today, we're going to set pi as 3.14. You might have a graphing calculator or a scientific calculator that has the exact value of pi. That's fine, but in the calculations I'm going to do is 3.14 in case you don't have a scientific calculator. So this is what we're going to use. So for this lesson, give exact values and approximations. So we give both to 2 decimal places. So example 1, find the circumference and the area of the circle. So we have radius of 2 centimeters. So let's go ahead and do that. Circumference, 2 pi r, 2 pi times 2, 2 times 2, 4. So circumference is 4 pi as the exact value. Approximately, right, this is our symbol for approximately. 4 times pi, right, 3.14, 12.56. So exactly is 4 pi, approximately is 12.56. Area, pi r squared, plug in 2, we get 4 pi. So area is 4 pi centimeters squared. Approximately 4 times 3.14, so area approximately is 12.56 centimeters squared. And they just happen to be the same. You don't run into that very often. B. Diameter is 6 centimeters. This means the radius is 3, right? 2 radii give diameter. Circumference, 2 pi r. 2 pi 3, 6 pi. So circumference is 6 pi centimeters. Approximately times 3.14. So circumference is approximately 18.84. Area, pi r squared, plug in 3, 9 pi. So area exactly is 9 pi centimeters squared. Approximately 9 times 3.14, so area is approximately 28.26 centimeters squared. Okay, time for some practice. Find the circumference and the area of the circle where r is 5 centimeters. Go ahead and pause the video and do that. Okay, we're back. So 2 pi r, 2 pi 5, 10 pi. Approximately 10 times 3.14, 31.4. Pi r squared, pi 5 squared, 25 pi. 25, 3.14, 78.5. And so these are our exact values and approximations. Okay, practice number 2. And for this problem, give approximation only, so no exact values, and you're going to give to 2 decimal places. So A, if the circumference is 10.3 centimeters, what is the area? B, if the area is 26 pi centimeters squared, what is the circumference? So go ahead and pause the video and answer that. Okay, we're back. So let's start off here. Circumference 10.3, which is the same as 2 pi r. So we set them like this. Divide by 2 pi, and so pi is 3.14, and so r is 1.64. We're looking for the area, pi r squared. Plug in our r, which gives 2.6896 pi, times 3.14 gives 8.45 as our centimeters, as our area of the circle. B. Okay, so the area is given to us, 26 pi, which is the same as pi r squared. Divide by pi on both sides, r squared is 26. Square root both sides, r equals root 26, like that. So circumference 2 pi r, root 26, like that. Pi is 3.14. We punch that in our calculator and we get 32.02 as the approximation of our circumference. Okay, practice number 3, bonus. You don't have to do it, but I highly recommend you do it. Derive the formulas. C equals 2 pi r and A equals pi r squared. Where do they come from? Go ahead and derive those formulas. Okay, and if you want to see the answer, just go back to the beginning of the video where I derived both of these formulas. And that's it. Have a good one, guys.